Hello, and welcome to our very first section, 1-1, on ratio and proportion. I hope you've watched my little intro to notes and video lectures video so that you can get an idea of why I do things the way I do. So if you haven't watched that yet, I think it's about 5.5 minutes. Watch that real quick. Okay, going forward, it says a ratio is a comparison using division of two quantities of the same kind, both usually expressed in the same units. So usually when you're talking about a ratio, you're going to have it's going to be, say, feet to feet or dollars to dollars. And a ratio is, again, as it's always been, a fraction. For example, the steepness of a hill can be written as the ratio of its height to its horizontal extent. So here we've got the height is 10 feet over the horizontal extent, as it's calling it, of 80 feet. And that can reduce to be 1/8. Something that we're going to be looking at that may relate to your career choice or something you're trying to work towards is a gear ratio. And in a gear ratio, you would take the number of teeth on the driven gear over the number of teeth on the driving gear. So example 1 says, find the gear ratio of the system if A is the driven gear and B is the driving gear, where A has 64 teeth and B has 16. Okay, so our gear ratio will be, it says we have to put the driven gear on top of the driving gear. So that'll be A to B. So 64 teeth to 16 teeth. And that reduces to 4 over 1. And sometimes that's written as 4:1, 4:2:1. Typical gear ratios that you may see are first gear is 3.54 to 1, second gear 1.9 to 1, and so forth. A gear ratio of 3.54 to 1 means that the engine turns 3.54 revolutions for each 1 revolution of the drive shaft. So you can read through that more if you need to. A pulley is a device that can be used to transfer power from one system to another. A pulley system can be used to lift heavy objects in a shop or to connect a power source to a piece of machinery. The ratio of the pulley diameters determines the relative pulley speeds. For example, find the ratio of the diameter of pulley A to the diameter of pulley B in this drawing. So it says A to B. So that means we're putting the diameter of A over the diameter of pulley B. So A was 21 inches. Important to keep our units here. B is 9 inches. And that reduces to 7/3. Or that can be written again as 7:3. Compression ratio. In an automobile engine, there is a difference between the volume of the cylinder space when a piston is at the bottom of its stroke and when it's at the top. This difference in volumes is called the engine displacement. Automotive mechanics find it useful to talk about the compression ratio of an automobile engine. Now, sometimes these slides, I may skip through them and say something like, you can read through this on your own. So if it's something that applies to you specific like this, then you could pause and read it instead of me reading it for you. The compression ratio of an engine compares the volume of the cylinder at a maximum expansion to the volume of the cylinder at maximum compression. So the compression ratio is the expanded volume over the compressed volume. Example 3 says, find the compression ratio of a gasoline engine if each cylinder has a maximum volume of 475 cubic centimeters and a minimum compression volume of 50 cubic centimeters. So the compression ratio is, as we were told in this previous slide, the expanded volume over the compressed volume. So the expanded volume here is the 475 cubic centimeters. And the compression volume, it says, is the 50 cubic centimeters. That reduces to 19 to 2. Now, it says compression ratios are always written so that the second number in the ratio is 1. So we have to reduce this to where there's a 1 on the bottom. So that would be 9.5 or 9.5 to 1, which it looks odd to have it in a fraction, but when you rewrite it as 9.5 to 1 like this, it's more visually appealing, I suppose. But it does have to be written with the 1 at the end. Example 4 says, as we learned previously, the pitch of a roof is the ratio of the rise to run. Where did we learn that previously? Anyway, where the run is half the span. For the roof shown below, the rise is 7 feet. The span is 48. So we need to find the rise over the run. That's the pitch. Well, the rise is easy. 7 feet. The span is 48 feet, but it says that the run is half the span. So our run is going to be half of 48 feet, or 24 feet. Okay? And we do want to reduce this. The reason being, it says roofers usually express pitch with a denominator of 12. So right now it's got a denominator of 24. We need to change it to where the denominator or the bottom number is 12. Now, how would we get from 24 to 12? Well, if we divide by 2, 24 divided by 2 is 12. If we divide by 2 on the bottom, we have to divide by 2 on the top. So we have 3.5 to 12. And that is the pitch. If you ever feel like I'm going too fast for an example, just all you got to do is pause, okay? I don't want to sit and wait for you to write things down and take up more time in the video in case someone's already got it done. So if you need more time, just pause it. Simple equations. To use ratio to solve a variety of problems, you must be able to solve a simple kind of algebraic expression. Consider this puzzle. I'm thinking of a number. When I multiply the number by 3, I get 15. What is my number? Well, 3 times what would get you 15? You can find that number in the box by taking 15 and dividing by 3. And so the number in the box becomes 5. So for example 5, it says a number multiplied by 40 gives 2,200. Find the number. So 40 times box is 2,200. So box would be 2,200 divided by 40, or 55. So the number that's multiplied by 40 to give 2,200 is 55. Now, if you've taken algebra before, which you probably have at some point in the past, you probably remember that we didn't use boxes, okay? We used numbers. They're called variables. So we may say 40 times n or 40 times x to signify our equation or our expression. Multiplication can be shown in several different ways. It can be shown with a dot. It can be shown when you're multiplying by a variable, you just have to write the number times the variable without anything in between. It can also be shown with a little x, which wasn't in this list, or you can put parentheses around one or both of the numbers. Example 6, we could change this to say 40n equals 2,200. And the way that we usually do this, if we'll say, well, what is on the side with the n that you need to get rid of? It's the 40, because we're trying to get n by itself. What operation is happening between the 40 and the n? It's multiplication. Ask yourself, what's the opposite of multiplication? Division. So we're going to divide both sides by 40. Those are usually the questions I go through in my mind or with students when solving equations. What do we need to get rid of? What's the operation? What's the opposite operation? So again, n would be 55. A proportion is an equation stating that two ratios are equal. For example, 1/3 equals 4/12 is a proportion. And this is equal because we know that 4/12 would reduce to 1/3 if we divided both the top and the bottom by 4. Notice that I just said that. So, when you're working with proportions, it's helpful to have a way of stating them in words. So we would say 2 is to 5 as 16 is to 15. Or as 6, is to 15. To solve a proportion, if there's an unknown in it, which there will be in many of our cases, we cross multiply. Cross products, it says if the proportion is a true statement, the cross products will always be equal. So if you multiply 1 times 12, you get 12. If you multiply 3 times 4, you get 12. And the cross product rule just says if you've got A over B equals C over D, then AD, let's do that in a different color, is equal to BC. Example 7 says find the cross products. So we're going to find 3 times 20, that's 60, and 5 times 12, that's 60. So looks like we have a true proportion. Example 8 says, consider this proportion. We want to solve for x. So what we do, same thing, x times 16, that's 16x. We usually don't write it as x16. We put the number before the variable, by the way. And then 4 times 12. And we continue simplifying. 4 times 12 is 48. And then to solve this, we're multiplying the x by 16. So to get rid of it, we divide both sides by 16. And x is 3. And if you were to plug this back into your proportion, you would see that 3/4 is equal to 12/16. For example 9, solve this one for n, it asks. So 6 times 10 is equal to n times 15, or 15n. So we have 60 equals 15n. Divide both sides by 15. And so n is 4. Note that the unknown quantity can appear in any of those 4 positions. So here, 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 or here can be the unknown. You may have noticed that the 2 steps for solving a proportion can be simplified into one. So here, we're taking 28 times 100. They denoted it with a dot over there, so I'll do that here. Equals 40x. And that ends up being 28 times 100 divided by 40, right? So if you wanted to cut down a step, you could just take one of the cross product that doesn't have an unknown, the 28 times 100, and divide it by the number in the cross product that does have an unknown. We can use proportion for lots of applications. It says, example 10, if the pitch of a roof is supposed to be 212, we'll say, and the run is 20 feet, what must be the rise? Okay? So the pitch is equal to the rise over the run. And we were told the pitch is supposed to be 2 to 12. When this is written 2:12, that's telling us, well, I mean, it'll matter in the long run that you put the 2 on top, okay? And then rise over run, we don't know what the rise is. It says the run is 20. So since we don't know the rise, that's what we're going to call, well, let's call it R for rise. So we cross multiply. 2 times 20 is equal to R times 12, or 12R. Divide those, we got to multiply first. 40 is equal to 12R then. Divide both sides by 12. And R is, 40 over 12. Or as a mixed fraction, that would reduce to 3 1/3 feet. Now, I'm not going to do this many times, but I am going to go to the side right now and tell you how to change a top-heavy fraction or an improper fraction to a mixed fraction. Okay? Like I said, I'm not going to do this much, but just in case you need a little review on that, here it is. And I know you can hear Willow meowing in the background, and I'm so sorry. Okay, so 40 divided by 12. It's 40 over 12. And so that's the same thing as 40 divided by 12. 12 goes into 40 how many times? Well, what's the biggest number that we can get out of 40? So 12 times 1 would just be 12. We want to get as close to 40 as possible while staying under it. 12 times 2 is 24. See if we can get closer. 12 times 3 is 36. That's the one we're going to need because if we do 12 times 4, we got 48 and it's too big. So now, 12 times 3 is 36, and so we subtract and get 4. Now 12 won't go into 4, so that means we have a fraction left over. So we end up with 3 and 4 twelfths. But the 4 twelfths has to be reduced. How do we reduce 4 twelfths? Well, find the number that will divide into both evenly. 4 will go into 4 and 4 will go into 12. Now you could use 2 because it will go into both of them, but you're not going to get far enough. You'd have to do it again, which is fine. For example, you can't use 3 though because 3 doesn't go evenly into 4. So it has to go in evenly into both. So we're going to divide both the top and bottom by 4. And that'll give us 1/3. So 3 and 4 twelfths is the same thing as 3 and 1/3 feet. Now, here's another side note. 3 and 1/3 feet is the same thing as 3 feet and 4 inches. Okay, so here's another side. Okay, how did we get 4 inches out of 1/3 feet? Well, 1/3 of a foot can be written as 1/3 of 12 inches. Of means multiply, by the way. And 1/3 of 12 inches is 4 inches. So that's how we got the 4 inches down here. Okay? So hopefully that alleviated a little bit of your concern for reducing fractions and changing units. We'll do more unit changes in future sections. Example 11 says, for medications provided in a liquid formation, the amount of liquid given to a patient depends on the concentration of drug in the fluid. Medication X is available only in a liquid formation with a concentration of 100 milligrams per milliliter. Suppose a physician orders 225 milligrams of medication X. Well, to determine the amount of liquid required, first note that 100 milligrams per milliliter means that 1 milliliter of liquid contains 100 milligrams of the medication. So we can start setting up our proportion like this. It says 100 milligrams for 1 milliliter. Now notice I didn't put that in a single fraction because usually when we do proportions, as you were told, that the units for each fraction wants to be the same. So I put milliliters on one side and milligrams on the other. And that helps you figure out where to put the 225 now because it should go under the milligram side. And now we can find medication X, how many milliliters of medication X there are. Cross multiply. Let's do it this way. So 1 times 225 is 225. And x times 100 is 100x. Divide both sides by 100. And x is 2.25. Don't forget your units, milliliters. So the patient would have to take 2.25 milliliters of this liquid in order to receive 225 milligrams of the medication. We are almost done. Last example. The pulley system of an assembly belt has a pulley diameter ratio of 4. Ratio of 4. Well, that sounds odd because a ratio is a fraction. What does that mean? Well, 4 as a fraction would be 4 over 1. We can always put a 1 on the bottom of a fraction. It says if the larger pulley has a diameter of 15 inches, what is the diameter of the smaller pulley? Now, how do we know whether to put the 15 on the top or are unknown? Well, it says the larger pulley has a diameter of 15 inches. So it needs to go on the top like the larger part of the ratio on the other side. So 15 inches has to go on the top because it's larger. And then our unknown, see, since it's a diameter, we'll call it D inches. Okay, cross multiply. 4 times D is 4D. 1 times 15 is 15. Divide both sides by 4. And we get 15 divided by 4. Or, let's see, as I said, I'd do this a very few times. Let's go to the side and see what that would be as a fraction. So 4 into 15. Well, the biggest number we could get is 4 times 3. Because 4 times 3 would be 12 with 3 left over. So that's 3 3/4. 3 3/4 inches. Don't forget your units. Okay. Well, that concludes our first lesson, and we got it in under 30 minutes. From here, what you'll want to do is go into my math lab and start working on your homework. And hopefully you've already watched my intro to my math lab video where it tells you the different ways that you can get help as you go through your homework. And then, of course, if the examples in my math lab don't help you, you can always shoot me an email.